sine of 330. When I go to 330, sine means the y. So what's the y at 330? Go to 330. Every single person's following along because I want everyone to do well in this. And also someone who's doing 30-2, you might halfway through the year realize you need 30-1 because you've changed your mind and what you want to do. So don't be one of those people being like, I don't need this. She just said it. Girl, you don't know. You don't know. I've had people have them. They're like, duh. They take 30-2 first, and then there they are sitting in my 30-1 going, oh, crud, I need this. So, yeah. You're going to have a blank unit circle you're going to fill in. So you have to be able to fill it in. And we're starting tomorrow practicing them. So tomorrow I'm giving you one at the beginning of class, Friday at the beginning of class, Monday at the beginning of class, a blank one, and you practice filling it in. So we have cos 330. 330 is what? What's the y at 330? Negative? 1/2. And then cos of 225 is negative root 2 over 2. And now we have a common denominator, so we can write it all over 2, and then we just rewrite the top. Negative 1 minus root 2. Done. That's exact values. If you're turning it into a decimal, you are doing the opposite of exact values. Exact values means not decimal, unless it was like a terminating decimal. If it was like 1.5, that's the exact value, right? But let's think about it. If it's like 1.6666666 and you round it to 1.6, is that the exact value you had on your calculator? No, so it's not an exact value. The only decimals that are actually exact are ones that terminate, so they stop. Like 1.25, you could actually put as an exact value. Okay? Tan of 330. I'm going to do that one off to the side because tan is more work, isn't it? Tan is those fractions over top of fractions. So we do tan 330 is y divided by x. Y is negative 1/2. X is root 3 over 2. So we get negative 1/2 times 2 over root 3, which gets us negative 2 over 2 root 3. What can I do with these 2's? Cancel. So I get negative 1 over root 3, which is lovely. But am I allowed to leave it in radical in my denominator? No, which is why we did radical unit first. So I'd have to rationalize it. So I get root 3. So I get negative root 3 over 3. So all that work gets me this. This equals negative root 3 over 3. Sine of 30. Not negative sine of 30, just minus. And then what's sine at 30? What's the y at 30? It should be 1/2. Now, can we put them together? Do they have common denominators? No, so this is why we did the rational unit before this as well. How do we get a common denominator between 3 and 2? GCF, what is the greatest between the two of them? 6. So, all these units build up to being able to do this. So we're going to multiply by 2, multiply by 3, and I get negative 2 root 3 over 6. Minus 3 over 6. Now this is what cracks me up, but also makes me sad. Then people start canceling them off again, and they get root 3 over 3 minus 1/2, and I'm like, you just undid your common denominator. You're like, I can take a 2 out. And you're like, boom, boom. And I'm like, no, you just put it on. Stop. So we write it all over 6, because we got the common denominator, and then we just rewrite the top. Negative 2 root 3 minus 3. Now, unless it can come out of all 3, you can't take it out. So this one's negative 2, this one's 3, this one's 6. Can I take something out of all 3 of them? No, I'm done. The error lies when people mess up. Now, you could do this. Try it out. Type tan 330. Make sure you're in degree mode. Type tan 330 minus sine 30 into your calculator. So go tan 330 degrees minus sine 330 degrees. I ate that to see if I... and get a decimal. Now, are we going to put that decimal down? On the floor. Are we going to write that decimal down? No, because it says exact value, doesn't it? But if I type this in, now type this into your calculator. If you have alpha y equals enter so you can get the fraction, use that. If not, you have to put the numerator in brackets and the denominator in brackets. This is the exact value, right? The answer you just got was the decimal value, wasn't it? They should what? They should match. They should be the same answer in decimal. So this is the answer I want, but you can check it. You can see if you're right. So you should get the same decimal, correct? If you don't get the same decimal, you oopsie. Often it's in people like reducing it more than they should. Okay? Sine of 270. Sine of 270. So I want the y at 270, which is -1. Cos of 90. I want the x at 90. 0. Plus 0. So this one is -1. Life is good. The next one is setting you up for a formula in 30-1. You don't know what this formula is. I'm just going to show you that it exists. So this is the sine A cos B minus cos A sine B. It's in sum and difference formulas that you're going to have in 30-1. This is literally just the actual answer. You don't need to know that part, but know that when we're doing this, this is math we're going to have to do in 30-1. So sine of 45. What's the y at 45? Root 2 over 2. What's the cos at 30? Root 3 over 2. What's the cos at 45? Root 2 over 2. And what's sine at 30? 1/2. The great thing about the sum and difference formulas that is for sine and cos, which you don't know them yet, but the great thing about them is they always get you common denominators. So you don't have to make common denominators next year, which is great. So, what happens when I multiply two radicals together? You multiply the outsides, 1 times 1, which is 1. And you multiply what's under the radical, so the radicand. Root 2 times root 3 is root 6 over 4. I find it really hard to not write 2, even though it's 2 times 2, which is 4. Like, I just feel like it's a common denominator. So that's where I err all the time when I'm doing this. And then I get minus root 2 times 1 is just root 2, because 1 times anything is itself, over 4. And now I have a common denominator. So I go root 6 minus root 2 all over 4. So these were the 4 questions for homework. Had you not done them, you kind of have them done. So there's that. Number 2 was also from your homework. Number 2 says, determine the value of x if the point x and 2/3 is on the unit circle. Remember I told you to either highlight it or box it. And on the unit circle means x squared plus y squared equals what? R squared. The unit circle has a radius of 1. So it would be 1 squared, which is 1. So when it says on the unit circle, we use the equation x squared plus y squared equals 1. So we're going to go x, remember we can rearrange it. So we can go x squared equals, we can subtract the y squared over. So we get 1 minus y squared. And then we can fill in. So we get x squared equals 1 minus 2/3 squared. So we get x squared equals 1 minus 4 over 9. So x squared equals 1 is just 9 over 9 minus 4 over 9, but you could just type it in your calculator. So x squared equals 5 over 9. Now when I square root, what did I tell you about this? You can separate them if one of them is a perfect square, right? And I have plus or minus because when you take the square root, you get positive, negative. So I can get plus or minus root 5 over root 9. And root 9 is just 3. Now, I can't give the answer plus or minus 5 over 3 because this one specifically states quadrant 2. And in quadrant 2, which is right here, are my x's positive or negative? Negative. So the answer is x equals negative 5 over, or sorry, root 5. I dropped that off there. Negative root 5. I don't like that. Okay? Okay, now this one you have to be able to spot. You have to be able to spot what the heck it's asking us. So it's giving us a trig ratio, and it's asking for the two more trig ratios, which tells me I'm going to need to find the third side, correct? So on a test, I would not normally give you a Cartesian plane to hint to draw it. You need to know to draw it, okay? And cos is x over r. That formula you will be given, yeah?
You lose a mark if you don't like draw later.
If you don't draw it, you might have the wrong sign on your y. Yeah. So in this case, it's between 180 and 270. So this is 180, this is 270, so I'm going to actually have a negative y. If you don't draw it, you'll probably have a positive y. You'll pick the wrong answers the whole time. Yeah. So that's why drawing it's so important. Because if you don't draw it, when you go to do, and you'll catch yourself. You should catch yourself if you didn't draw it. Because when you go to solve it out, you're going to get plus or minus an answer, right? Well, plus or minus isn't going to work. I'm going to need either positive or negative. Well, how do I know? I have to draw it. Okay? So I always draw the bow tie reference triangle. And I have x is equal to negative 2. And the moment I draw this, I go y equals negative, and I know I'm going to have to find out what it is, but I put a negative sign there because y's are all negative in quadrant 3, right? And then my r is 5. So I need to solve for y. Now I'm not going to use x squared plus y squared equals 1, because this doesn't say anything about being on the unit circle, does it? So people don't know when they're supposed to use both, one or the other. Well, if it says on the unit circle, that's why the radius is 1, correct? Is the radius 1 this time? No, it's 5. So I'm just going to use x squared plus y squared equals r squared, because it doesn't say on the unit circle. Now I want to solve for y, so I'm going to subtract the x squared over. So I'm going to get r squared minus x squared. So y squared equals 5 squared minus negative 2 squared. Y squared equals 25 minus 4. Y squared equals 16. Square root, and what must I remember? Plus or minus. Whenever I take the square root myself, I have to have a plus or minus sign. So I'm going to get y equals plus or minus 4, but because I drew it, I know that it's negative 4. Anything in quadrant 3, x and y are both negative. So it's not the positive. Now I need the other two primary trig ratios. So I need sine theta, which is y over r, and I need tan theta, which is y over x. So sine, 25, it's 19. If only it were 16, that'd be a much nicer answer. Disappointing. Oh, it's 21. I wanted to subtract 6. Oh, and it's recorded, my stupidity. That's awesome. Okay. Why? Oh, it's not small. Now going into singing. 21, which doesn't break down. Oh, man. It's fine. So y equals negative root 21, which is not at all 16, which is 4. Now this one's actually nice because the two trig ratios we have to find both actually have y's on the top, and y is the ugly radical, right? If it was the other way and it was in the denominator, you'd have to rationalize it, but both of these have y's in the top. So you can just fill them in. So sine theta equals negative root 21 over 5, and tan theta equals negative root 21 over negative 2, which is just root 21 over 2. Then we're going to flip over. Okay, given the trig ratios below, determine the reference angle of each. How do we do reference angles? The moment I ask for a reference angle, I'm going to inverse trig, whatever it is, cos, tan, or sine, of what? What must it always be? Yeah. They always have to be positive. Remember, even if their answer is negative, to get the reference angle, you always take the positive. So when we go to reference angles, we're always going to take the positive fraction. Because then it'll make you find your answer in quadrant 1. So, theta equals cos neg 1 of root 3 over 2. Theta equals what? Everyone should try it. Second cos root 3 over 2. We're using all of this for today's work. Second cos root 3 divided by 2. Bracket. Enter. You should get 30. Did you get 30? 30, 30, 30? So 30 degrees is my reference angle. Now this one, we're going to do theta equals sine neg 1 of 2 divided by 3. I don't know what that is. It's not a perfect one. It's going to be a decimal. It's going to the nearest whole degree. We're doing the positive. So what did you get? Anyone? Yeah. 42? And then the tan, we're going to go theta equals tan neg 1 of 4 divided by 3. So theta equals what? 53. That makes sense? Okay, we're going to go back to our notes. Back to our notes. And we're going here. There's example 1. We're not going to that one. We're going to example 2. It's page 6. We're going backwards. Page 6, example 2. So we did do example 2, but we just did the trig ratios. So it says, suppose theta, and these are the 2 different questions you can get, and this is where trig isn't hard, it's just deciding what the heck they're asking you to find, honestly. That's where people struggle in grade 12 too. It's like, yes. If I'm like, oh, you have to do the trig, like, I'm like, oh, you have to find R, you're like, or, oh, you have to get the reference, yes. But until then, you're like, they all look the freaking same. I don't know what you're asking me to do. Okay? So example 2, it says, suppose theta is an angle in standard position with a terminal arm in quadrant 4. So we drew that terminal arm, didn't we? It was in quadrant 4. And we drew a reference angle, we drew our triangle, and we found sine and cos. We agree? We defined the third side, and then we did sine and cos. We did that, correct? I said we're going to come back to this, because we didn't finish it off. Then it says, the measure of the reference angle to the nearest degree. So that's what we're doing today. We're finishing this comma part. Measure of the reference angle to the nearest degree. How am I going to get the reference angle? If they gave me tan theta equals negative 1/5. You find the reference angle. We just did these in the quiz. So if I give you tan theta equals negative 1/5, on page 6, you find the reference angle. We're on page 6, example 2. So we're finding the reference angle right now. Tan theta equals negative 1/5. Page 6, example 2. We've already done half the question. So to get the reference angle, we're going to do theta equals tan neg 1 of 1 divided by 5. We always do the positive, right? It doesn't matter if it's negative, it doesn't matter if it's positive. To get the reference angle, we do the positive. What is that to the nearest whole number? 11? So we have the reference angle. Then it wants the angle in standard position. Your angle in standard position is the angle from the x-axis to the terminal arm. That's the standard position angle. So I'm going to label all around this thing here first. So this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360. So I'm going to label all my angles around it. Okay? If they ever want an angle in standard position, you just need to find the reference angle and you're almost there. We've already done reference angles and found standard position angles. We've done this before. The reference angle is the little angle from where to where? What's the reference angle? The little angle from the x-axis to the terminal arm. Right? The reference angle is the little angle from the x-axis to the terminal arm. I call it the bow tie angles. So the ones from the x-axis to the terminal arm. So we have a reference angle of 11 degrees. This is not drawn to scale, just so you know. Because, like, look, it has me here. So I'm going to do a little erasing. Because my drawn to scale crap. You guys have it drawn already. Oh, I pressed eraser, but it didn't let me. You have it drawn already, so don't worry about erasing it. The scale isn't as big of a deal. I'm just showing you so that you can see. So 11 degrees would be like 11 from the x. Remember, 45 is halfway, 30 is halfway between there. So like 11 would be like here, right? So in here to here, here to here is my 11 degrees. We agree? So how do I get my angle in standard position? My angle in standard position is from here all the way to here. How do I get an angle in standard position in quadrant 4? We do the same steps always and always. David? 360 minus 11. So to get our standard position angle, whenever you're in quadrant 4, you just do 360 minus your reference angle. Slanted, that's a slanted L is like, means angle. 360 degrees minus 11, which gets me 349. And I'm going to label it. Okay, what I want you to do is just grab out a totally separate sheet of paper. It can be blank, it can be lined, it could be anything. I don't really care. On a separate sheet of paper, we're going to practice and practice and practice and practice and practice and practice and practice. So separate sheet of paper that you're going to want to put with your notes. So separate sheet of paper. Okay, given sine theta equals -3/4 in quadrant 3, determine the angle in standard position. So given sine theta equals -3/4 in quadrant 3, determine the angle in standard position. So whenever you're given a trig ratio, and asked for angle in standard position, sketch is your first step. So we need to sketch this. We need to sketch the angle in standard position. Is it going to be accurate? No, that's why I wrote sketch. Angle in standard position. I don't even know what the reference angle is, so this is going to be very sketchy. That's fine. We don't need it to be perfectly accurate. We can either erase and make it accurate, or we can just leave it not accurate. So we need to sketch the angle in standard position. So the first thing I always do is I label my arms, right? So I go 0, 90, 180, 270, 360. Next year we're going to go in opposite. So we're going to go 0, negative 90, negative 180. We go counterclockwise. This year, not so much. We can always just go to 360. Okay? So we want to sketch it. How do we know where it's sketched at? What part of the green writing tells me where the heck to sketch that? Quadrant 3. Yeah, that gives me a hint. Quadrant 3. So you have to watch, because this one's the easiest way, because it gives you actually what quadrant it's in. We're not going to always get that. So we have our initial arm here, because it always starts on the x-axis. And then somewhere in quadrant 3, we have a terminating arm. Now, is this the most accurately sketched graph? Now, I have no idea what the reference angle is. It could be 11, and the arm would have to go up here. It could be 87, and the arm would be way closer to 270, correct? But does it ask me to sketch a perfect sketch and then give me the angle? No. It just wants the angle in standard position. That's why number 1 it says sketch, because it can be sketchy. I don't care. So we sketched it. We know it's here. Now, if I knew one more thing, I could get the angle in standard position. What's the one more thing I'm going to need? Yeah. Your reference angle. If I have my reference angle, when the moment I have my reference angle, I have this angle. And in quadrant 3, when I have my reference angle, I just go 180 plus it, right? So I just need the reference angle. So step 2 is determine the reference angle, which we've practiced over and over and over. It was on our first day. Well, second day, actually. Sorry, not our first. So to determine the reference angle, we have to take the positive of that, right? So we're going to go theta equals sine neg 1. Instead of negative 3/4, it's going to be at 3/4. What's that to the nearest whole degree? 49? Ah, it's kind of actually kind of well drawn. So this is 49 degrees in here, because our reference angle is our bow tie angle. It's the angle from the x-axis to the terminal arm. We agree? That doesn't change. When we're in quadrant 4 and we had the reference angle, we took 360 minus it, got our angle, correct? When we're in quadrant 3, we do 180 plus the reference angle. And you can just visualize it. So this takes me 90 to get to here, 180 to get to here, plus another 49 will get me here, correct? So quadrant 3, to get that standard position, we're going to do theta equals 180 degrees plus 49 degrees, which is 229. Did that make sense? That makes sense? Step 1, sketch. Step 2, find reference angle. And then step 3 would be your standard position. Get your answer. Okay? So that's if I ask you for standard position and give you a trig ratio. So trig ratio and ask for standard position. So we're going to go number 2. Now it's going to change. I'm not going to always just give you the quadrant. So we're going to practice a couple more with quadrant, and then I'm going to show you how I can change it. So 2. So we do given tan, that's supposed to be a tan, theta equals negative 5 over 4 in quadrant 2. Determine the angle in standard position. So our first step is to sketch it. So I have 0, 90, 180, 270, 360. Okay. Now I need quadrant 2. Use different. That might be the not very accurate. Okay. And step 2 is to get the reference angle. And it equals, theta equals tan neg 1 of 5 over 4. I always put the positive in. What did everyone get for the answer to 1, or to no decimal places, the whole number? 51?
Yeah.
Not the least accurate drawing I've ever had. So from here to here is 51. So is the bow tie angle. So from the x-axis up or the x-axis down, right? Bow tie angles. So we are going to try and get this angle. In quadrant 2, when we're given the reference angle, we always do 180 because it gets us the whole way to the x-axis. Subtract off the reference angle, right? So theta equals 180 minus 51, which gets us 129. So in quadrant 4, you do 360 minus the reference angle. In quadrant 3, you do 180 plus the reference angle. In quadrant 2, you do 180 minus. And in quadrant 1, it is the reference angle. Quadrant 1 is the easiest one. So in 30-1, it's usually never asked there, because that'd be too easy. So your homework is going to be this. Write it down. So you're going to determine the angles in standard position. Flip. That in is not important. It just flipped to blue. So tomorrow we're going over ones that I don't just give you the quadrant. So we're going to go over ones where we're going to use cast rule. Cast rule is important. You have no idea what it is. And you shouldn't. If you do, yay. And if you don't, you shouldn't. It's never been tough work. Yeah.
We're going to go over like the questions you guys just read.
I just did. They were on your quiz. Number 1 and 2 were the questions on your quiz. They were the questions from your homework.
Yeah.
So we went over them, Bowden.
I didn't realize that. I never put 2 and 2 together.
I told you, though. I swear. Did I say
I
that?
did say it.
Okay. It's okay. You're normally listening 100%. Today it was about 70. It's fine. Can't be on all the time. Can't be on all the time. That's just way too hard, right? Most people are used to trying to do math and like GTA at the same time. So now you're just doing math. I feel like you need to be doing more. You're not. Yeah, I know these things. All right, good. 1. Tan theta equals 4 over 7 quadrant 2. These we're going to go over tomorrow. Sine theta equals negative 3 over 7. I like 7. Quadrant 3. And then 3, we're going to do tan. I already did tan. I'm going to do cos. Cos theta equals negative 6 over 11, because that sounds fun. Quadrant 4. Tomorrow we're going to do ones where I don't give you the quadrant. I'll give you something like cos theta equals negative 6 over 11, and tan is less than 0. So with saying tan is less than 0, it tells you what quadrant it's in. For you, it makes no sense today because you haven't learned cast rule. But that's just how it changes. It just won't give you the quadrant. It'll say. And instead of saying quadrant 4, I could have said this. This is another way I could say it. 270 is less than or equal to theta is less than or equal to 360. That's another way of saying quadrant 4, right? It's the exact same thing. Okay? So these are your 3 questions. Enjoy them.